So Spark is actually designed to be, it is a platform to be very, very fast, general purpose and easy to use. And in general, it is a extended MapReduce processing framework, you can say. Since MapReduce is just a way to process the huge amount of data that we call a big data, to process and to store that data into the HDFS and for further processing. So what MapReduce is does, it decrease the complexity and it divides into the phases, short, shuffling and map, short, shuffling phases, and then process the data. But in Spark, it is a in-memory kind of process, and the main agenda here for Spark, to develop a Spark, is it maintains a cluster. It has its own cluster management. When I say its own cluster management, it means it does not need any external memory or external processing system to process the data. And a large, huge amount of data can be processed in a very fast speed, which is a, we can say, a legacy in MapReduce that if we compare about the MapReduce and Spark, MapReduce is a legacy between it, because it is a slow process, and the problem is when we have a huge amount of data, then MapReduce hangs sometimes. So what is Spark? It uses a yarn, it uses a standalone, it can be used as a standalone, it uses a Mesos. Mesos is actually a massive parallel processing, and it uses a basic Spark course, that is a Spark SQL, Spark Streaming, MLib. MLib is a machine learning library for processing data into the Spark. It uses graphics, it uses different kind of packages also. So as I already described, Apache Spark is an open source processing engine built around the speed, ease of use and analytics. If you have a large amount of data that requires low latency processing and a typical MapReduce program that cannot provide, Spark is that alternative. We can do all things using Spark, whatever things we are not able to achieve through MapReduce. And yes, it is 100 times faster than MapReduce in memory calculation. Because of its in-memory computation quality, it is a more superior or more beneficial to use Spark. Spark combines SQL, streaming and complex analytics together seamlessly in the same application to handle wide range of data processing scenarios. Yeah, this I already described earlier. So, Spark, as I shown here, it runs on yarn and it runs on top of HDFS. So, I will describe here in future slides why we are using Spark, because it is a replacement of MapReduce, as I have explained earlier. Spark uses the HDFS, that is a Hadoop distributed file system, and as you can see, it is depicted in this diagram. Spark uses this HDFS. Spark can be used standalone. Spark can use yarn. Spark can be deployed but not fully monitor or manage. It is basically used for analytics, workflows, and that also processes in memory. So now I will explain what is the Spark stack. This whole thing covers Spark stack. What Spark stack contains? That Spark core, Spark SQL, Spark streaming, MLib, and graphics. So Spark core is general processor system that providing scheduling, distributing, and monitoring of the application across the whole cluster. No matter how big it is, but it is a very fast processing and scheduling system. That is the Spark main quality, you can say. The Spark core is designed to scale up from 1 to 1000 of nodes. It can run over a variety of cluster managers including Hadoop, Yarn, and Apache Muses. Or simply it can run as a standalone with own built scheduler. Spark SQL it is just like a SQL queries, and in Spark we can write our own customized or user-defined queries also. So it is a design to work with Spark via SQL or HiveQL. Hive is also a data processing system. It is a big data technology only. It is a ecosystem, one of the ecosystem of Hadoop to process the data and to monitor the data, you can say. Spark SQL allows developers to intermix SQL with Spark's programming language supported by Python, Java, and Scala. So what is Spark programming language? Basically, the main Spark programming language is Scala, and it is better to use Scala inside whenever you are writing a Spark or whenever you are using a Spark. So Spark SQL supports Python, Java, and Scala. Spark Streaming provides processing of large streaming of data. If there is any real-time data is coming, so what streaming does it? It provides processing of large streaming data. Available, as I have told earlier, is a machine learning library, and that provides multiple type of machine learning algorithm. All of those algorithms are designed to scale out across a cluster as well. So it is a machine learning algorithm. There are various algorithms present and that can be used inside the Spark, and yeah, it contains a R&D part also. Now graphics, it is a graph processing library with APIs to manipulate graphs and performing graphs for parallel computations. So there is one more feature inside this Spark. You can use this RDD, resilient distributed datasets. It is a fundamental data structure of Spark. It is an immutable distributed collection of objects, and each dataset in RDD is divided into logical partitions, which may be computed on different nodes of the cluster or in the same node also. RDD can be contain any type of Python, Java, or Scala object. Primarily Scala means it is a core language of Spark, including user-defined classes. And RDD is a read-only partition collection of records. RDD can be created through deterministic operations on either dataset, on stable storage, or either RDDs. And as we have already known that it is a fault tolerant. All the Hadoop ecosystems are fault tolerant. It means even any error or even a disgrading in any component occurs, then also it will continue the process and it will not get any down procedure. So there are two ways of creating RDDs. One is to parallelizing an existing collection, or the second one is referencing a data set. When I say referencing a data set, it means in an external storage system such as shared file system, HDFS, HBase, or any data sources offering a Hadoop input format. And when after creating RDD offers two types of operation on it, either transformation or actions. Transformations that do not return any value, and action is they do return values, and when transformation get evaluated along with actions, it is called RDD. So this is all about the Spark. Now move on to Scala. If you talk about in basic terms, it is an extension of Java, or the abbreviation of Scala is scalable language. It is a modified or the very latest version of Java 8 if you compare in terms of programming, or you can say. So it is a general purpose programming language designed to express common programming pattern in a concise, elegant, and type-safe way. Scala supports both object-oriented and functional programming. If Pure object oriented means every value in Scala is an object and every operator is a method call. This is the main logic when we learn Scala, that every value is an object inside the Scala. So Scala jobs can be written in Scala, Python. Spark jobs can be written in Scala, Python or Java. APIs are available for all three. Spark shells are available for Scala or Python, but the native language is Scala, so it is obvious that we should use Scala inside the Spark. This is the function declaration as I have shown. Difference, definition, function name, list of parameters, return type. These all things we need to mention when we are declaring any function inside the Scala. Now move on to next slide. What is the characteristics of Scala? Scala is object oriented. It means everything in Scala is the object. The primitive type that can be defined by Java, such as int, boolean, or are objects in Java. Functions are objects in Scala and will play an important role in how applications are written for Scala. Scala is functional. It runs on JVM. As I have already described that it is similar to Java, and if we talk about it is very similar to Java 8. Scala and Java 8 are most likely the same functionality and the features they are having. So this is all about the Spark and Scala for today's session. Apache Spark is an execution engine that broadens the type of computing workloads Hadoop can handle while also tuning the performance of big data framework. That concludes the session now.